Hi, this is LunshiLu. Today we are going to look at 3 tutorial questions. First of all, evaluate this integral. Now we can do this way. Use substitution u equals x plus 2. Then your du becomes dx. When x equals 0, you got u equals 2. When x equals 1, you got u equals 3. We'll come back to there's a little 2 here. Your x becomes u minus 2 times log of u du. Then it becomes u times log of u du minus 2 log of u du, and use the partial differentiation, you get this. Then you substitute 2 and 3 into it, becomes 9 on 2 times log of 3 minus 9 on 4 minus 6 times log 3 plus 6 minus 2 log 2 minus 1 minus 4 log 4 plus 4. Notice that your 2 times log 2 becomes log 4 here. Then you got the answer. 3 on 4 minus 3 on 2 times log 3 plus log 4. Then we do part B. Use the substitution x minus 2 equals square root of times tan of u to evaluate the integral. Now we have x minus 2 equals square root of tan of u. Then u becomes arctan x minus 2 on square root of 3. The du becomes square root of 3 on x squared minus 4x plus 7 dx. That will be dx divided by square root of 3 equals 1 on x squared minus 4x plus 7 dx. When x equals 3, u equals pi on 6. When x equals 5, u becomes pi on 3. You can do an integral like this because 1 on x to the power of 2 minus 4x plus 7 to the power of 3 on 2 equals 1x plus 7. 3 on 2, that would be 1 plus 1 on 2, so it becomes this. This will be your du on root 3. So we take your root 3 out here because it's a constant. That becomes x squared minus 4x plus 7 to negative 1 on 2 du. Now we can use this to form a perfect square. This becomes x minus 2 to the power of 2 plus 3. And that will be our root 3 tan of u. So this will be your root 3 tan of u to the power of 2 plus 3. This to the power of minus 1 onto du. This will be 3 10 to the power of 2u plus 3 to the power of minus 1 onto du. Now we have proved that integral of this and this are equal. Careful, it's no longer the integral of this one from 3 to 5 because we have substituted with x minus 2 equals root 3 of tan u. Then when x equals 3, your u becomes pi on 6, and x equals 5, your u becomes pi on 3. Then integral of this would be tan u times 3 times tan to the power of 2u plus 3 to the power of negative 1 on 2. Then you substitute pi on 3 and pi on 6. Don't forget to times root 3 of 3. Then, and that would be your answer. For the next question, region R will be the area bounded by y equals e to the power of x, line y equals 1, and y equals 1, sorry, that would be x equals 1, and the y-axis. Then it is rotated around line x equals minus 1. That looks like you dig a hole in here and here. So its area, sorry, its volume would be from 0 to 1 here. 2 pi times the absolute value, because we don't have a minus value for its volume, e to the power of x minus 1 times 1. To evaluate this integral, and we get rid of 2 pi because it's a constant, and e times e to the power of x times x, e times, and your minus 1 times x would be minus x times e times 1, e to the power of x times 1 would be e to the power of x, and minus 1 times 1 will be minus 1. Then you do it separately. And your integral will becomes minus 1 on 2 times x minus 2 e to the power of x plus 2, then times 2x. You substitute 1 and 0, that will be 2 pi times 2 to the power 2 times e to the power of x minus 3 divided by 2. This got cancelled, so your answer would be 2 times e to the power of x minus 3 times pi. For the first question, we are looking at the population growth with a converse model, and the derivative of the function will be c times log of k divided by p times p. Notice that c is a constant and k is the carrying capacity here. Part A, we need to solve the differentiation equation. The dp on dt equals c times log of k divided by p times p, and your and this part comes to the left hand side, and your t comes to the right hand side. That will be this one. So you integrate those sides at the same time. Got c is a constant, so we got your 1 on c times integral of 1 on p times log of k divided by p dt time equals t. So let u be log of k divided by p. So your du would be minus 1 on p dx. So left hand side becomes 1 on c. This part will be minus 1 on u du. Then it becomes log of u to the negative divided by c, and your u equals log of k divided by p, so it becomes this. Your right hand side would be t, so it equals each other. It would be log of k divided by p equals minus c times t. So we have log of k divided by p equals e to the power of minus c times t, and k divided by p becomes e to the power of minus ct. Then p becomes k divided by e to the power of minus ct. Your p becomes k times e to the power of negative e to the power of negative c times t. Question part B will compute the limit of p when t approaches infinity. Well, now we can do this without looking at part A, because we know that the carrying capacity is k, so your p population cannot be greater than k. So the limit will be k. So you prove it, because this part here, as t approaches infinity, it becomes 0. E to the power of 0 equals 1. So your p would be p times. So your limit will be k times e to the power of 0 equals k. Part C. The graph will look like this. When it has its initial value equals 100, and this will be t equals 0, and when t equals 0, the p value becomes 100, and as t approaches infinity, you got the carrying capacity equals 1000. So this approaches 1000. So the difference between the logistic growth and this composite growth would be your logistic growth looks like this when its midpoint equals, when it has its midpoint when t equals 0. For part D, we want to find its maximum growing speed of p. So first of all, we find out its second derivative. When it equals 0, p has the fastest growing speed. That will be p dash dash equals the derivative of the first derivative. That will be, you see, take out the constant, the derivative of p times log of k divided by p. And finally, you got c times minus 1 plus log of k divided by p. When equals 0, 0 equals c times minus 1 plus log of k divided by p. So you divide by c at the same time. It becomes this, and your minus 1 comes to the left hand side, and you got 1 equals log of k divided by p. When equals 1, that will be e. So your p equals k divided by e. When p equals k divided by e, it has its maximum growing speed.